Assalamu alaikum, students. Today I'm making a video for the revision of pure mathematics revision pack um, for end of term 2 final exams. Here is the study list. Okay, so I'll go to our first chapter, which is, that differentiation. So let's start revising differentiation. Before I go to the content, I just want to revise with you from MF19 the most important formula for the exam. Number one, for differentiation, guys, you need to understand if it is written ln of x, its derivative is 1 over x. But the extended version of this thing is the derivative of ln of ax plus b. Okay, it is equals to 1 over ax plus b, and further derivative of ax plus b, and it is a. You got it? So this is the derivative of ln of x. Then we have exponential functions. So derivative of exponential function ax plus b, it is the same, but you have to take the further derivative of ax plus b, which is a. Same thing for sine, cosine, and tan. Okay, and the derivative of sine of ax plus b, derivative of cosine of ax plus b, derivative of tan of ax plus b. So derivative of sine is cosine of ax plus b times a. The derivative of cosine is minus sine of ax plus b times a. And the derivative of tan is secant square of ax plus b times a. Right? This is not needed. Then this is needed for the exam. Inverse tan of derivative of inverse tan of x, which is 1 over 1 plus x squared. Clear? So this is needed. Then after that, they also give you the product rule here. Can you check? This is product rule. What is the product rule? If I want to take the derivative of uv, okay, leave u, take the derivative of v, plus leave v, take the derivative of u. However, there is a quotient rule. Be careful in applying the quotient rule. Whatever you see in the denominator, you write v squared, and then you copy v, the derivative of u, then minus u dot v derivative. For parametric equations, if x is x in terms of t, you find dx over dt from here. Y in terms of t, you find dy over dt from there. Then chain rule is dy by dx is equals to dy over dt times dt by dx. So now I substitute the values here, which I found from these results, put them here, and then you can find dy by dx. So parametric differentiation technique is also given in MF19. In integration, this is famous power formula, which everyone knows. If I have to find the integration of ax plus b raised to the power n, its formula is ax plus b raised to power n plus 1 over n plus 1 multiplied with a. You took it in AS level. But here I'm needed this formula. When you have a linear factor down, ax plus b d of x, okay? So its formula is ln of ax plus b and divided by the coefficient of x. This is needed. Integration of uh, e of ax plus b. It is e of ax plus b divided by a. Integration of sine, be careful. Integration of sine, it has minus cosine of ax plus b divided by a. And then integration of cosine of ax plus b will be sine of ax plus b divided by a. And the integration of secant square of ax plus b, which is tan of ax plus b divided by a plus c. So these three formulas are needed. Then this formula is very, very important, but I have given you in the class the modern version. The modern version is 1 over a squared x squared plus b squared. If it is written like that, you guys have to write 1 over AB inverse tan of AX over B. So this formula you have to do. No need. This is for further maths. This is for further maths. However, they gave you integration by parts, but Mr. Omar gave you a different integration by parts formula. What was that? That was leave you integral of V minus big integral sign, and same thing with the integral of V. And here you write the derivative of U with dx. This is integration by part technique. So 3 marks question will be coming on integration by parts or product rule of integration. Another important question which carries 2 marks in the final exam. And if you have a function down and the function's derivative is on the top, then you simply write ln of f of x. And that's all with the skills which are given in the MF19. So let's start, guys, the questions. I want to find the derivative of these exponential functions. You remember, I will get the same answer, 7x e raised per 5x minus 4 e raised per x cubed. But is my job over? No. What is the further derivative of 7x? The further derivative of 7x is 7. What is the further derivative of 5x minus 4? Which is 5. What is the further derivative of x power 3? Which is 3x squared. If you want to write it in a beautiful form, you can write e raised to power 7x. You can write it as 5e 5x minus 4. You can write 3x squared e raised to power x cubed. Okay, now let's move on to the next question. I want to find the derivative of these 3 functions. First of all, it has only e. I'm going to write same thing. What? No need to write dy by dx because we know that we are finding dy by dx. Okay, can I copy it? 4e2x. Can I copy it? Minus 2e square root of x. Can I copy it? 3e 1 over x. I have to take further derivative of what? 2x. Further derivative of square root of x. Further derivative of 1 over x. I think in this way you guys can understand what is the meaning of further derivative. Okay, that's why I am doing it in one more extra step. Okay, so can you copy e raised by 2x? What is the derivative of 2x? Mr. Omar, this is 2. And the final answer will be 8e2x. Okay, and can you apply the power rule on it? Minus 2 e raised per square root of x. Power rule says power goes back, and from the power you take off 1. And can I cancel 2 with the 2? Minus e square root of x dot x raised per. What is this? This is minus 1 over 2. Leave it here. Okay. I want to apply the power rule. Can I write it like this? X raised power minus 1. Okay, good. So 3 e raised power 1 over x, apply the power rule, minus 1 goes back. And from power, I take off 1. So my final answer is minus 3 e raised power 1 over x, x raised power minus 2. Now I go to the next question. This thing, I want to tell you guys, we have a very powerful power formula. So whenever you see, I want to take the derivative of any function which is given under the power, you have to apply the power rule first. So power goes back, and from the power, you subtract minus 1. Then chain rule says you have to take the further derivative of f of x. So I will cite f dash of x. This is called chain rule. So, but you have to apply the power rule first. So what Mr. Umar is going to do, guys, I'm going to apply the power rule. So 2 goes back, and from the power, I take off 1. Can I keep this function as it is? Yes. Copy it here. 2e 3x minus 1. Is my job over? No. Mr. Umar, you have to take the further derivative of 2e 3x minus 1. Okay, so I am writing it categorically so that everyone understands why Mr. Omar is taking the further derivative. Okay, now let me do the steps. So 2e 3x minus 1 raised power 1. What is the derivative of this thing? The derivative of this thing is 2e 3x, and the further derivative of 3x is 3, and the derivative of 1 is 0. Can I write it in a beautiful form? This is 6 and this is 2. So I can combine them. Which will give to me 12e3x. And I copy this one, 2e3x minus 1 raised to power 1. No need to expand it, just leave it. If you see this type of question, always try to split them. So 1 over ex separate and ex over ex separate. Once you split it, now can I write it in a beautiful form? Yani use indices properties. When this power goes up, it's power negative, and this is cancelled plus 1. Now I'm ready to apply the derivative. Same answer, and the further derivative of minus x is minus 1, and the derivative of 1 is 0. So my final answer is minus e minus x. Now, very important question for the final exam, guys. Okay, so let's check why this is important, because it has two exponential functions. It's very easy. First of all, can I copy it as it is? I'm going to copy it as it is. Okay, e minus 4x plus 2. What is the further derivative of minus 4x plus 2? It is minus 4. Then I have to write plus 7 plus 7. What is the derivative of e raised to power 5x, 5 minus 2x? Same. Okay, shall I take the further derivative of 5 minus 2x, which is minus 2. Now let me write it in a beautiful form. Minus 4 e raised to power minus 4x plus 2 and minus 14 e raised to power 5 minus 2x. That's all with the exponential functions derivative. Now I came to the ln functions. Hurry up, boys. Ln derivative. Ln means I have to reciprocate. So 1 over 9x plus 2. And the further derivative of 9x plus 2, it is just 9. So my answer will be 9 over 9x plus 2. Now, can I take the derivative? Reciprocate. The derivative of ln tells you reciprocate your argument. So ex minus 3x. Now, can I take the further derivative of this? Ex is ex and minus 3x is minus 3. So if you want to write in a beautiful form, so ex minus 3 on the top and ex minus 3x in the denominator. Here I have 4. Ln tells you I need to reciprocate 1 over 8x, and the further derivative of 8x is 8. So can I cancel 8 with 8? And my final answer will be 4 over x. Now here, before applying the ln property, can I use the, before applying the differentiation, I need to use the ln property. Ln property says that I have to send the power back. So 7 ln 5x minus 1. I'm ready now to apply the derivative. This will stay as it is. Ln tells you reciprocate your argument. Okay, I reciprocated it. Now next further derivative of 5x minus 5 is just 5. So can I write my answer in much more simplest form? So 7 times 5 is 35 over 5x minus 1. Now this question, guys, I will suggest you can use ln property, ln1 minus ln of x squared. I think it will make your life easier. Why? Because boys, you know, ln of a over b, you learned that it is equal to ln a minus ln b. So I'm going to use that property. What is the derivative of 1? The ln of 1, it is 0. Can I use the, hold on guys, let me use the ln property, then we do the derivative together. So can I send this 2 back by using ln property? So ln of 1 minus 2 ln of x. Ready? So I'm ready to apply the derivative. What is the derivative of ln of 1? It is 0 minus 2. ln of x, it is 1 over x. And the further derivative of x is 1. Final answer comes to me minus 2 over x. I hope it is clear to you. Now, in this case, I have to copy 3, guys. 3 ln means reciprocate your argument. Okay, then the further derivative of 4x is 4. Cancel 4 with the 4, and my answer is 3 over x. Can I use the ln property, boys? Hurry up. So 2 ln of 1, okay, minus 2 ln of, or what do you need to do, guys? You can put the brackets on, or you can write it as 2 ln of x power minus 1. That would be easier for you. So minus 1 goes back, so it becomes minus 2 ln of x. I'm ready to apply the derivative. So minus 2, and this is 1 over x. So I can say my answer is minus 2 over x. I use the indices properties, okay? In this case, my friends, Mr. Omar is trying to use the ln property. So allow me 6 ln of 9x minus 2 plus, sorry, minus 6. Did you see 6 is multiplying? So 6 ln of 9x minus 2. And then I write minus 6 ln of 3. Got it? Now let's do the properties. 6 as it is. ln tells you reciprocate 1 over 9x minus 2. Further derivative of 9x minus 2 is 9 minus, this is constant, guys, its derivative is 0. So 9 times 6 is 54 over 9x minus 2. If you don't like this, I have a method number 2. So you write 6, reciprocate. So 3 goes up and 9x minus 2. And then the further derivative of 9x minus 2, because 9x over 3 minus 2 over 3. What is the derivative of that? The derivative of 3x is just 3. Wallahi, same answer will come to you like this. This is up to you, use any technique. But I love to apply the ln property, ln of 6 ln of a minus 6 ln of b. 6 has to be behind the ln's because 6 is multiplying. However, ln of a minus ln of b. And you know 6 ln of 3, when I take the derivative, its derivative is 0 because this is constant. 6 as it is, reciprocation, and the further derivative 9x minus 2 is 9. And my final answer is 54 over 9x minus 2. Okay, so ln properties are very, very suitable for me. Now, when I solve this question, guys, I need to write it as 5 ln 7 minus 2x raised power minus 1. Okay, so dy by dx will be equals to 5, reciprocate 7 minus 2x raised power minus 1. Further derivative of 7, it is 0. Here minus goes back, any minus 2, minus goes back, and from the power you take off 1, which is minus 2. Now, can I write my final answer, boys? This is 2 and this is 5, so it is 10. I'm going to write here 10 x raised power minus 2 over 7 minus 2 raised power x minus 1. I can simplify it furthermore, but no need to simplify it. Okay, now next question. Y is equals to 4 ln of, can you write the square root as 1 over 2? The power on the argument, yes, like that. Can you use ln property before applying the derivative? So half goes back. So 4 times 1 over 2 ln of x squared minus 8x. Now 2 cancel with 4, so y is equals to 2 ln of x squared minus 8x. Now I'm ready to apply the derivatives, guys. Dy by dx, okay, 2 as it is. ln tells you reciprocation of x squared minus 8x. And what is the further derivative of x squared minus 8x, which is 2x minus 8? And then you leave it here. Now, can I use the ln property? Y is equals to ln of 7 minus ln of x plus 3 raised power 6. Also use ln property, which is 6 goes back, 6 ln of x plus 3. Now I'm ready to take the derivative, dy by dx. ln 7 is a constant, its derivative is 0, minus 6, reciprocation, 1 over x plus 3. Further derivative of x plus 3, it is 1. My final answer is minus 6 over x plus 3. So now I'm done. So we need to do now product rule of differentiation, which is, we learned uv. What is that? U as it is v dash plus v as it is u dash. Here, this is u and this is v. I leave e2x as it is. Derivative of x cubed minus 3 is 3x squared. Then I leave x cubed minus 3. What is the derivative of e2x, which is 2e2x? If you want to open the brackets, it's allowed. You can do the expansion. Now, I want to again apply the product rule. This is u, this is v. I leave the u, 2x plus 1. Now, what is the derivative? Apply the power rule. Power goes back, and from the power, you take off 1, which is 3. Further derivative of x minus 5 is 1. Okay, plus then x minus 5 raised to power 4, and derivative of 2x plus 1 is just 2. So you can leave the question here, 4, 2x plus 1, and x minus 5 raised to power 3 plus 2, x minus 5 raised to power 4. However, you can take x minus 5 whole power 3 common, and you can simplify it furthermore, but I'm stopping here. Now, for the quotient rule, guys, whenever you have the two function in division form, their derivative, as I told you, v squared, then v u prime minus u dot v prime. So this is u and this is v. I'm going to write as x squared plus 1 whole squared, and x squared plus 1 as it is. The derivative of x cubed is 3x squared minus x cubed as it is. The derivative of x squared plus 1, it is just 2x. Open the brackets. It's better to open the brackets, guys. So it is 3x4 plus 3x squared minus 2x4 over x squared plus 1 whole squared. Now, can you simplify them? It gives you x power 4 plus 3x squared over x squared plus 1 whole squared. Now we reach to the derivative of trigonometric functions. Be careful. So dy by dx, guys, the derivative of sine is cosine. Write 5x as it is. What is the further derivative of 5x? 5. So my answer is 5 cosine of 5x. Okay, what is the derivative of 6? 6, sorry, 6 is the coefficient as it is. Derivative of tan is secant square x over 2. What is the further derivative of x over 2? The further derivative of x over 2 is just 1 over 2. 2 cancel with 6, it gives you 3 secant square x over 2. Now this question, the derivative of cosine, it is minus sine, boys. X squared 2x as it is the argument. The further derivative of x squared plus 2x will give you 2x just plus 2, and leave the question like this. Now next, very, very important, boys, this question, because you know now you have a power here. So this power means I have to apply the power rule first. What is the power rule? I told you, if I take the derivative of any function which is under the power, so power rule says power goes back, and from the power you take off 1, and then chain rule tells you you'll take further derivative of the function. Here I apply the same thing. Let's apply. So allow me to do this. 4 as it is. Okay, power goes back, 2 goes back. So from the power, you take off 1. Okay, I am done. Now what is left to me? Tan. What is the derivative of tan? It is secant square of x. What is the further derivative of x? Which is 1. Final answer is 8 tan x secant square of x. Here I have sine. Derivative of sine is cosine x cube minus 7. And then further derivative of x cube minus 7 is 3x squared. So I can write it as 3x squared cosine of x cube minus 7. Now come to this question. We have 5. So 5 as it is. Derivative of tan is secant square 4x. What is the further derivative of 4x, which is 4? Can I multiply 4 with 5? It is 20 secant square 4 of x. Next, we have cos cube x. Can I apply the power rule? So the power goes back, and from the power you take off 1, yani this is 2. So 3 square of x. Till now I just applied the power rule. Now next is, what is the derivative of cosine? The derivative of cosine is minus sine of x. What is the further derivative of x, which is 1? Can I write my final answer? Minus 3 cosine square of x sine of x. Now here I have to apply the product rule. This is u and this is v. Okay, what I'm going to do, I keep the u as it is. What is the derivative of the cosine, which is minus sine of x, plus then leave cosine of x, and the derivative of sine to x is, come on, it is cosine of 2x, and the further derivative of 2x will be 2. So I can write in a simplest form, minus sine of 2x sine of x, and plus 2 cosine of x, and cosine of 2x is the final answer. Now in this case, this is u and this is v. I leave x squared, and the derivative of tan is secant square 3x, and the further derivative of 3x is 3. Done. Then leave tan 3x. The derivative of x squared, it is 2x. Can I write it in a beautiful form? 3x squared secant square of 3x plus 2 tan of 3x. That's all. 2x. 2x tan of 3x. Now we came to the implicit functions. So in implicit functions, be careful in the final exam. You have to make, if it is y squared, the derivative of y squared is 2y dy by dx. But if it is x squared y squared, you have to apply product rule. So leave x squared, the derivative of y squared is 2y dy by dx, and plus y squared as it is, and the derivative of x squared is 2x. So don't forget, guys, maybe in the final exam in implicit equation, I checked your product rule skills. So x squared derivative is 2x. Come on, minus 3 minus 3. Can I apply the power rule on y power 3, which is 3y squared, and the further derivative of y is dy by dx. And what is the derivative of 4y squared? It is 8y. Come on, it's dy by dx. Okay, now can can I send this whole thing to the other side and take dy by dx common from them? So 2x is equals to 8y plus 9y square dy by dx I have taken common from both of the term on the right hand side. So now this term is multiplying, and on the other side it divides. The final answer is 2x over 8y plus 9y square is equals to dy by dx. Clear? Now we have inverse tan came, very important for the final exam. This type of a question, be careful. What is the derivative I have taught you? The derivative of inverse tan of x, it is 1 over 1 plus x squared. Now I'm going to apply that technique here. 5 as it is. Okay, what is inverse tan derivative? It is 1 over whatever you see here under the square. Done. Is my job over? Now further derivative of 3x is 3. So my final answer is 15 over 1 plus 9x squared. Now I have to apply here x cubed, which is 3x squared. I have to apply the product rule. X as it is, the derivative of y squared is 2y dy by dx, and then you leave y squared. What is the derivative of x, which is 1? So guys, can you see I have applied the product rule here? And what is the derivative of 5x, which is just 5? Now I keep 2xy dy by dx here and send the rest of the values on the other side. Which values? Y squared and 3x squared on the right hand side. So this becomes minus 3x squared and minus y squared. Then finally dy by dx, guys, is equal to 5 minus 3x squared minus y squared over 2xy. Now, allow me to apply the product rule here. So this is u and this is v. X as it is, what is the derivative of ln of y? 1 over y and dy by dx plus what is ln of y? Keep it. And the derivative of x is 1. So I have applied here the product rule. And what is the derivative of 1? It is 0. And the derivative of x, it is 1. Keep x over y here dy by dx, and this ln of y on the other side, it is minus ln of y. Now I want to make dy by dx as a subject. Sorry guys, when it goes to the other side, because 1 is already there. So 1 minus ln of y. Now when I send it to the other side, so y goes up 1 minus ln of y and divided by x. That's the final answer. Now here I'm going to apply the UV method, the product rule. So dy by dx, hurry up, ex as it is. What is the derivative of inverse tan? 1 over 1 plus x squared. And the further derivative of x is 1. No need. Plus inverse tan of x, you write it as it is. And what is the derivative of ex, which is the same. And you leave it like this. Now we come to the parametric differentiation. So it gives you dx over dt. Don't forget it, guys. This is in terms of t. So I'm going to get dx over dt. What is that, guys? It is 3 times 2, 6t squared. And from here, I'm going to get dy over dt, which is 8t. Got it? After finding these two values, guys, I'm ready to find my dy by dx. And dy by dx is always equals to dy by dt times dt by dx. Okay. What is dy by dt I have? It is 8t. And what is dt by dx? Reciprocated 1 over 6t squared. Cancel them. So it is you are getting 4. And this is 3. T cancel with this one. And I get 4 over 3t. Now from here, I'm going to get dx over dt, guys. It is 3t squared minus 6. And this will give you, can I write it as 2t raised to minus 1? So this is giving you dy by dt. The derivative of t is 1. And the derivative of 2 minus 1 goes back from the power. I subtracted 1. So minus 1 is minus 2. My dy by dt is coming to me 1 minus 2 t raised to minus 2. What I want to get dy by dx, which is equals to dy by dt times dt by dx. What is dy by dt I have? Dy by dt, I found it 1 minus 2t raised to minus 2. And reciprocation, what is this? This is 3t squared minus 6. Halas, you stop it here. Now, parametric equation dx over dt, guys. 3 integration of differentiation of cosine of t is minus sine of t. What is that? Dy by dt is 2 cosine of t, and I want to find dy by dx, which is equals to dy by dt times dt by dx. And so what I'm gonna write, 2 cosine of t times 1 over minus 3 sine of t. You can leave it here, or otherwise you can also write it as minus 2 over 3 cot of t if you want it. This is dx over dt, guys, 8t, and this is dy over dt, which is 8, and I want to find dy by dx, which is equals to dy over dt times dt over dx. So dy over dt is 8, and dt by dx is 1 over 8t. Cancel 8 with the 8, and the answer is 1 over t. Next question. This gives you dx over dt, which is 1 minus cosine of t, and this gives you dy over dt, which is equals to 0 minus and minus sine of t, which is sine of t. Dy by dx, it is equal to dy by dt, which is sine of t times 1 over 1 minus cosine of t. You can leave it here. Can I write it like this? 1 minus t raised to power minus 1. It would be easier for me to apply the derivative. So dx by dt, apply the power rule. Power goes back, and from the power, I take off 1, which is minus 2. Don't forget the further derivative of 1 minus t. The further derivative of 1 minus t is minus 1. Now this minus and this minus will make it plus. Only I'm left with 1 minus t raised to power minus 2. Now from here, dy by dt, it gives me just 2t. So chain rule says that I want dy by dx. So what is dy by dt? It is 2t. Reciprocation 1 over 1 minus t raised to power minus 2. You can leave here, or you can send the powers up. So anyways, guys, this is the video I wanted to prepare for differentiation. Next video, I'm going to send it to you for integration. Assalamu alaikum wa rahmatullahi wa barakatuh.